I smell you hobbits as you come back to Pocket Ronnie.
Okay, we're going to be doing three variables, which means we have to have three equations to solve it. So if you look at these, we're going to be doing 30D, 7 through 12, and I have three different equations, A, B, C. Each of them have three variables, X, Y, and Z. My Z's will always have a line through them. My 2 and Z's look very similar, so this is a 2, this is a Z. My Z's will have a line through them. You use elimination to solve. So my best recommendation is to always look at your coefficients in front of your variables. So we are going to pick two of these equations and use elimination to get rid of one variable. So I always like to look and see if there's any equation that does not have a coefficient in front. This is the only one in your X's that's where it doesn't have a coefficient. Every other letter has a coefficient in front of it, okay? So I'm going to choose to use equation A. So I'm going to label everything so that you can see what I'm doing. This is equation A, so I'm going to use equation A, and I'm going to pick one of these other equations and stack them one on top of the other to use elimination. So I'm just going to do B, equation B. And again, I'm going to stack them one on top of the other. And then I'm going to use elimination. Elimination is where you're adding them. And you can choose whichever variable to eliminate. So I'm picking X's because this one doesn't have a coefficient. So it'll be easier to eliminate. If this is a positive 3, this needs to be a negative 3. So if I'm going to multiply that by negative 3, I have to multiply everything by negative 3. Okay, so I'm going to drop down and rewrite my new equations. So for A, after I've multiplied everything by negative 3, that will be a negative 3x, a positive 6y, negative 12z, and a positive 12. I didn't do anything to equation B, so it stays the same. Okay, I'm going to add these together. Those two eliminate. 6y plus 4y, 10y, negative 12z, negative 5z, in debt 12, in debt 5, means I'm in debt 17, and then adding those, 37. I'm going to call this equation 1. Because now what I'm going to do, what I have to do, is I took two equations and I eliminated X. Now I've got to take two different of these original equations and eliminate the same variable. So I've got to take two of these equations. So I'll pick A and B again. I am going to pick A again because it has no coefficient in front. So I'm going to pick A. So over here I'm going to take equation A. Again, why am I picking this one? Because it has no coefficient in front of the X. And I can't choose B again, so therefore I'm going to choose C. I've got to pick two different equations. So this time I'm going to pick A and C, and I have to eliminate the same variable. Since I eliminated X over here, I have to eliminate X again. So I'm going to add these equations. How do I eliminate X? Well, this is a positive 5x, so I have to multiply this by a negative 5x. If I do a negative 5 to that, I have to do a negative 5 to everything. Okay, so now I'm going to rewrite these equations. These problems are just a matter of keeping up with your steps. So my new equation for A is negative 5x plus 10y minus 20z equals positive 20. Keep up with your signs. I didn't do anything to equation B, so I can just rewrite that. Remember, I'm adding these together to eliminate. Those go away. 10y and a negative 3y, positive 7y, negative 20z, positive 2z, negative 18z, and then 32. I'm going to call this equation 2. So, do you see what I've done here? I took two of my original equations, I eliminated x. Then I took two separate equations. Actually, this should be equation C. I took two separate equations and eliminated the same variable. I eliminated x in both of them. So then I ended up coming up with an equation with y and z, and then I came up with a second equation with y and z. So now I can take these two equations and do elimination again. So to do elimination again, I need to take equation 1 and then equation 2. This is why I'm labeling them, to keep up with them. And I stack them on top of each other. And then I do elimination again. You can choose whichever one you eliminate. Neither one of them look like they eliminate easy. So I can't multiply anything to 7 to get 10, and I can't multiply anything to 10 to get 7, and the same with 17 and 18, or negative 17 and negative 18. These are smaller numbers, so I'm going to use these. So basically, I have to ask myself, what can I turn both of these into? Okay, what are they? I need to pick the same multiple for each one. Well, I can turn them both into 70. How do I get this to be a 70? I multiply it by 7. So if I multiply that by 7, I have to multiply everything by 7. Well, how do I get this to be a 70? Multiply it by 10. But see, they're both positive. In order for them to eliminate, when I add them together, one has to be positive and one has to be negative. So if I'm going to make this a positive 70, I need to make this a negative 70, which means I need to multiply it by a negative 10. Negative 10 times a positive 7 would be a negative 70. If I multiply this by a negative 10, I have to multiply everything by negative 10. So this time in elimination, I had to multiply something to both equations in order to get one of my variables to eliminate. So I'm going to rewrite my equations. So equation 1, multiplying everything by 7. This would be a 70y minus, I think that, let's see, 119, and then 7 times 37, 259. Equation 2, negative 10 times 70, negative 70. Negative times a negative is a positive. 10 times 18, 180, that was z. Negative times a positive is a negative. 10 times 32, 320. Now I can add these two equations together. My y's will eliminate. Now I can, negative 119 and a positive 180 is a positive 61z. And then 259 and a negative 320 is a positive 61. Negative, I'm sorry, that should be a negative because that's higher. Negative 61. Dividing both sides by 61. Z equals a negative divided by a positive, negative. 61 divided by 61, 1. So Z equals negative 1. Not done, because now we've got to solve for x and y. So how do I solve for x and y? Well, going back to these two equations, I only had y's and z's. So I can take this z and put it back into one of these to solve for y. So I'm going to take this and put this in back right here to solve for y. Okay? So, but I'm going to write that down here. So my equation that I'm substituting into is 7y minus 18z equals 32. I said z was negative 1. So to solve for y, I can put in negative 1 right there for z. So 7y, negative times a positive, positive 18. Subtract 18 from both sides. Just make sure I get my numbers right. That should be what, 4, yeah, 14. 7y equals 14. Divide both sides by 7. Y equals 2. Okay, So I know Z, I know Y. How do I get X? I can take Y and Z. Now it's like you're going backwards. You start from the bottom and now you're following all your stuff back to the top. So you take Z and Y and go back and substitute into one of your original equations, your A, B, or C equation. Because I know Y, I know Z, so now I can solve for X. So I'm going to use equation A. So I'm just going to rewrite equation A down here. This was equation A. X minus 2y plus 4z equals negative 4. I know y, I know z. So I'm going to plug those back in. X minus 2 times y, and y was 2, plus 4 times z, and z was negative 1, equals negative 4. So x minus 4 equals negative 4. Indet 4, you're in debt 8. Add 8 to both sides. X equals a positive 4. So you have now solved for all three variables. X is 4, y equals 2, z equals negative 1. If you're on a 3D graph, this actually represents a 3D coordinate. This actually represents an X, Y, Z coordinate. So if you're going to write it in coordinate format, you don't have to for this class. I just want to point it out. If you're going to write this in coordinate format, it would be 4, 2, negative 1. And that's when you're on a 3D axis, and X, Y, and Z axis. Having them individually is just fine. Okay, we actually need to do one more thing. We need to check it because the very last step of the problem actually says to check. I'm only going to check in one of the equations. So, since we came up with X equals 4, Y equals 2, and Z equals negative 1, to check it, you take all of these solutions and put them back into one of your original equations, and the left side should equal the right side. I already used equation A to actually solve for X, so I'm going to use equation B to check. In theory, you can put this back into every equation and the left side should equal the right side. I am only checking one of the equations. So now I'm going to put in X, Y, and Z for each one. So 3 times, and X was 4, plus 4 times, Y was 2, minus 5 times, and Z was negative 1. Now the left side should equal the right side. 3 times 4 is 12, plus 8. Negative times a negative is a positive. 12 plus 8 is 20, plus 5 equals 25. And I can see that 20 plus 5 is 25, and so I can see that that checks. Okay, we're doing 30C, 7 through 12, and I have these three equations. Again, my suggestion is to look at the coefficients. Look and see if there's any letters that do not have a coefficient in front. This equation has coefficients in front of every variable. This equation has a coefficient in front of every variable. This equation has a coefficient in front of every variable. So when I see that, there's no easiest way to do it. So then I start looking at my numbers and look to see if anything is a multiple of something else. So I've chosen, it's like chess. You have to look at the moves ahead and say, if I do this, what will happen? Well, I've already looked ahead and I've chosen to eliminate y's. So again, what I need to do is pick two equations and then eliminate one variable. So I can see that 2y and 4y. At least 2 is a multiple of 4. So I'm going to use equations A and C. So then that means I have to rewrite those equations. I'm going to label them so that I can keep up with which equations I'm using, A and C. So I'm picking two equations to stack on top of each other so then I can use elimination to get rid of one variable. Again, you're adding them. I'm choosing to get rid of my y's. So if I have a positive 4y here, I need to have a negative 4y here. Well, how do I get a negative 4y? I have to multiply by a negative 2, which means I have to multiply each one by a negative 2. So I'm going to come down and rewrite my equations after changing them. Multiplying equation A by negative 2, I'll get negative 6x minus 4y minus 8z equals negative 18. I didn't change equation C, so I'm going to leave it the same. Now I'm adding the two variables, or the two equations together. Those go away. A negative 6x and a positive 5x is just x. Indet 8, indet 3 is indet 11, z. Negative 18 and 8 is negative 10. I'm going to label that equation 1. So I used equations A and C to eliminate y. So now I have to go pick two different equations and eliminate the same variable. So if I eliminated y, I need to eliminate y again. Okay? So I'm just going to use, there's no easy way of picking two other equations, so I just pick A and B. So if I use equation A, and equation B, remember you have to use two different equations and you have to eliminate the same variable. So if I eliminated y before, I have to eliminate y again. Well, there's nothing I can multiply to 2 to get 3 and vice versa. So I look at, I can turn them both into a 6. These are both positive, so one of them has to be negative. So I'm going to multiply this first. If I multiply this by 3, then that means that will be a 6y. If I multiply it by 3, I have to multiply everything by a 3. And that will become 6y. Well, then I need this to be a negative. If this is a positive 6y, I need this to be a negative 6y. How do I get this to be a negative 6y? I need to multiply it by negative 2. Which means I need to multiply everything by a negative 2. So I'm going to rewrite my equations. I'm labeling them just so I can keep up with them. So this is equation A with multiplied by 3. So 3 times 3x, 9x, plus 6y, plus 12z equals 18. 27. Okay, equation B. I'm multiplying everything by negative 2. So it would be a negative 8x minus 6y plus 4z, keep up with your signs, equals a negative 12. Now I'm adding those together and my y's eliminate. I should be eliminating the same variable that I did over here. So now I'm adding my x's, positive 9x, negative 8x would be a 1x, and then positive 12, positive 4, positive 16, z, 27 minus 12, 15, make sure I did that right, and I'm going to call this equation 2. So these two equations should have the same variables in them. This one has x and z, this one has x and z, because I eliminated y in both of those other ones. So now I can take these two equations and do elimination on those again. So I take those equations, I'm just going to change my color so it doesn't get all crazy. I'm going to rewrite them and stack them one on top of the other and do elimination again. Okay, here it's an easy choice. I don't have any coefficients in front of my x's, so I'm going to eliminate those. So I'm going to multiply one of them by a negative 1. So I'm just going to do this top one. Multiply everything by negative 1. So I'm just going to rewrite this over here. I'm just labeling it just to keep up with what everything is. So that would be a negative x plus 11z plus, equals a positive 10. Equation 2, I didn't change it at all. Now if I add my equations, those will go away. 11z plus 16z, positive 27z. Okay, all of these answers should come out to a even whole number, no fractions, no decimals. So I knew that I did something wrong when I was going to come up with a fraction. I found my mistake. Up here, -6 and +5, you may have caught that when I did it. -6 and a +5 will be a -x. So this equation 1 down here, let me erase all this. So this equation 1 down here, that x should be negative right there. So these are already going to eliminate right now. So we don't have to go through this process of multiplying by a -1. So I'm going to erase that. So they eliminate in the form that they're in right now. If I did it correctly to begin with, that would be a -x. Here's equation 1. Here's equation 2. Those eliminate right there. +16, -11 would be a +5z. This is a 5. -10, +15, +5. Divide both sides by 5, and z equals 1. Okay, now we need to solve for the other variables. How do we do that? We're just going to go backwards in our steps. Z equals 1. I can now put that back into equations 1 or 2 to solve for x, because this equation only has x's and z's. So if I have z, now I can solve for x. So I'm basically going to take this and put that in right there. So x plus 16 times 1 equals 15. So that would be 16. Subtracting 16 from both sides, x equals -1. Now I need to solve for y. How do I do that? I now take x and z and now go back to my original equations. My original equations of the a, b, and c equations. Okay? It doesn't matter which one you pick, you're going to get the same answer. So I'm just going to rewrite equation A. I'm going to use equation A, which was 3x plus 2y. This was one of the original equations given in the problem. I'm going to use that. So I now know z, and I now know x, which means I can solve for y. So taking 3 times, and x was -1, keep up with your signs, and z was 1. So that means -3 plus 2y plus 4 equals 9. Combining these two, a -3 and a +4 is 1. So it's 2y plus 1 equals 9. Subtract 1 from both sides. 2y equals 8. Divide 2 to both sides. And y equals 4. So now that you have all three answers, that's your solutions. All three of them. Now you can check. The very last step is to check. You can check it into any of the equations. Since I just used equation A here, I'm going to use a different one just to show the process of checking. I'm going to use equation B. Theoretically, you're supposed to check it in every equation to see if the left side equals the right side. I'm only checking it into one of them. So I'm using equation B, which this was the original equation given in the problem, equation B. So I know each one of these. I know my x, I know my y, I know my z. So I'm going to plug those back in to this equation. So 4 times x was -1, plus 3 times y was 4, minus 2 times z was 1 equals 6. 4 times -1, -4, plus 12, minus 2 equals 6. When you have addition and subtraction, you go left to right. -4 plus 12, +8, minus 2 equals 6. 8 minus 2 is 6, and so it checks. If your solutions are correct, every one of these equations should check out when you put those solutions back into them.